Hello, good evening.
Good evening, sir.
Yes, good evening. Okay. So, in the previous class, except those two projects, I have left it to you. The module 3 is completed. Okay. You understood various things related to the OS modules and the shell utilities module and zip file module. Okay, how to read the files from the zip file, how to uncompress it, okay, extract all the files which are there inside a zip file, and how to extract the specific files from the zip file, and then how to compress the files also, add the files into the archive. This is what you people understood in the previous class. So now the module 4 is all about classes and objects. So now we go for understanding the object oriented concepts. So using the Python, how to create the classes, how to create objects, something dealing with the OOP concepts, object oriented programming concepts, by using the Python programming language. The complete module 4 is based on this class assigned objects. Now, till now, you understood various types of built-in types, various built-in types, say for example int, float, string, list, dictionary, tuple, all these things. Now all these things are classes in Python, and you people were not knowing till now all these built-in types what we've understood so far were the classes. But strictly speaking, these are all the classes in Python, because I don't know whether you people have noticed it or not. So whenever I declare a variable of type integer, and if I am interested in knowing the type of it, so I used to pass it as an argument to type function, and it used to tell me it is of type class int. Okay, and that clearly shows that every built-in type in Python is of type classes. Say for example, I'll take a is equal to 1. So this is what I'm writing. I'll just say type of a now. So type of a is int, okay, and so it is basically divide the type of int, I think. Okay, it says only the type, but it is of type class. So these are all the classes, okay, implemented basically in the form of the classes. Next. Okay, these are all the built-in classes what we understood, and there is a need for us to write our own user-defined compound types now. Now how to define the user-defined, how to write the user-defined compound types. Now my own type I need to write. Say for example, now I want to represent a mathematical point, and all of you know, to represent a mathematical point in a 2-dimension you require two numbers, or it's called as the coordinates. Okay, and these two coordinates together form a point. Now I need to define my own compound type in order to define a point in Python. So in mathematical notation, the points are often written inside the parentheses with comma separating the coordinates. Say for example something like this. So represents the origin, 0, 0 represents the origin. Similarly xy represents the point x units to the right and y units up the origin. Okay, something like this we represent a point within the mathematical notation. But the same thing when I want to represent in Python, how do I represent? Okay, now what is the natural way to represent a point in Python? So there are first we'll understand the quick and dirty solution for representing a point in Python. So one natural way to represent a point in Python is to use two floating point values. So and these two floating point values you can go for representing either by using a list or a tuple. But this is not a complete solution. So this is a quick and dirty solution, because grouping the two floating point values either by using the list and the tuple will not serve you the purpose, because list and tuples are used for totally different purpose and not for representing the point, okay, or a mathematical point. Now we got to define, and when I say list, it can be a list of any numbers. So now when I say a point, either it should be two floating point values or two integers, or one floating point and one integer. Now when I take a list, it can be a list of anything. You can have list of strings, list of characters, you can have list of integers, list of floating point values, or even you can go for having mixture of all these types. So that is the reason I said list will not serve you the purpose for defining the point. And then tuple also same. So you can have tuple of 2 values or tuple of 3 values, any number of values you can have inside a tuple, but again they can be of varying types, and again this is also not suitable for defining a mathematical point in Python. Okay, and all these things, the list and tuples, whatever we understood, are not best suitable or are not the best choice for defining the mathematical point. Okay. So then, what is an alternative solution? An alternative solution to all these things is to use a class. Okay. Now, using a class, you can go for defining your own compound type, and that compound type, what you define, will have its own limitations, its own boundaries. So now, if I am defining my own compound type to define a point within a Python programming language, it has its own boundary. Now any operation what I want to do, I got to do within that boundary, within that fencing. So outside that I cannot go. And so this was not possible in case of what the other built-in types like list or the tuples. It's not like I cannot represent a point by using a list or a tuple. I can do it, but so they don't define the boundary for it. Okay, but class will always do that. Okay, so and this approach involves a bit more effort is required, because you got to define your own compounded type. So your effort is necessary, but so the effort what you put will bring you many advantages. The advantages which you are not getting, using the list and the tuples for defining a point or any other object, not necessarily the point. The example what I've taken here is the point. Okay, and we'll just look in how to create a class first. So very simple it is. So to define a class within the Python programming language, and it's something similar to any other compounded statements what you have written till now. So you have written many compounded statements. You have written if statement, you have written else statement, you have written for loops, you have written while loops. So exactly similar to that. Okay, so it looks the same compounded statement what you have written till now. See, class point. So this is the keyword, and point is the name given to the class, and I can say this is a compounded statement because you can see the colon here. That means under the statement you can go for having a set of statements. So and then what I have written right now under this class is pass. Now whenever, please make a note, whenever you're writing a compounded statement, at least one statement should be there inside it. So you cannot just leave it blank. Now if I don't have anything to write inside the class point, I have to just say pass. So pass is something like which takes some mission cycle and does nothing. Okay. Hope you understood how to create a class. Hello.
Yes, sir.
Okay. Now syntax rules. Okay. Now when you are defining the class, what are the rules you got to follow? Okay. So class definition can appear anywhere inside the program. So is there a fixed location for writing the definition of the class? So nothing as such. So within the Python programming language, a class can be defined anywhere, wherever you want. Okay. And there is no, it's not like the class should be always defined at the beginning or at the end or somewhere here between this and this. No. So it can be defined at any location or anywhere within your program. Okay. but they are usually near the beginning after the import statement, usually. But there's no hard rule saying that the class should be always defined at the beginning after the import statements. No, there is no hard rule, anything such that, okay, anything like that. Now you can go for defining the definition of the class anywhere inside the program, but generally what we do, or usually what we do, we prefer it writing near the beginning of the import statement. Just after the import statements we go for writing the definitions of the class. And what are the other rules, syntactical rules? The class definition is same as the other compounded statements, as I mentioned earlier, such as loops and the conditional statements. So we have written the if-else statement, which is a compounded statement. A compounded statement is nothing but a statement which can group several other statements within it. Okay, so it follows the same thing. If you just have a look here, it is of the same syntax or the same structure. And the previous definition here, the definition what I have written here, it creates a class called as point. Okay, and the pass statement which is written inside it has no effect. Okay, no effect, because it is only necessary because a compound statement must have something in its body. So you cannot just write a compound statement without anything inside it. Python will not accept it. So if you want to write a compound statement, okay, without any statement, okay, it is not possible. Python will not allow you. Such cases you can go for writing this pass statement, which does nothing. So now you understood how to define your own compound type within the Python programming language, Python program, by using the class definition. Now the next thing is, so after creating this class, you should go for creating the instances of the class, or instances, or else you can also call them as objects of the classes. Okay, so by creating the point class, we created new type, also called as a point. The members of this type are called instances of the type or the objects. Now how do we create a new instance for my class? So the new instance for the class is created something like this. So blank is equal to point. Okay, so blank is the instance which I am creating right now. It is an instance of the class point, and this, what is this point is? So you can guess this. Whenever I say a class should have a constructor. So this point is a function which is nothing but the constructor. So the variable blank is assigned a reference to a new point object. So a function like point that creates new object is called the constructor. So now this is the constructor function here, and we have created an instance for my class point with the name blank. Like this you can go for creating any number of instances for the class point. So right now I've created just one instance with the name blank. Now, okay, you understood how to define a class and how to create an instance for the class by using the constructor. And constructor, it takes the same name as the class name, and that is what you saw it here. Okay, point is the name of the class, and the name of the constructor is also a point, and this is the blank is the instance created to my class. And if you want, you can also go for passing the arguments to your constructor. Okay, so I think parameterized constructors and non-parameterized constructors, or default constructors, something like that. Now how to define the attributes of the data? So class is done, next instance of the class is done, or the object of the class is done. Next, how do you add the attributes of the data? So a new data or attribute can be added to an instance using the dot notation. So you can see this, the dot notation is used. Name of the instance is blank, and I want to define a data under this instance with the name x is equal to 3.0. So this is the attribute name and this is the value. And then similarly blank.y is equal to 4.0. Okay, so if I want one more instance to be created, okay, say blank 1, I just say blank 1 is equal to point, and then I can go for again assigning the values of attribute values for the blank 1 as well. Blank 1 dot x is equal to say 10.0, blank 1 dot y is equal to 20.0, correct? No? Now when I take the attribute x with, correct, no? And if I'm viewing the attribute x from the instance blank perspective, its value is 3.0, and similarly if I view the value of the attribute x from the other instance blank 1, correct, no? So its value will be 10.0, something like that. Now this syntax, correct, no? Assigning the values to the attributes of an instance is something similar to assigning the values to the normal variables or accessing the normal variables which are defined in other modules. Say math module we've used. So inside the math module there is a variable with the name pi. Now how to access this variable pi? By writing the name of the module dot pi, something similar to that. Now class is an blank is an instance of the class point, and to access the attribute x I use dot operator, dot notation. And similarly string dot uppercase, string is what? String is an instance again, okay, the module name dot uppercase, okay, and then string dot punctuation. So this, and even the class, when you're defining the attribute and assigning the values, it gets the same syntactic rule as the selecting the variables from the module. It follows the same syntactic rule. And then if you view this pictorially, it is something like this. I have a blank, so which is pointing to this some memory location, which has two attributes, x with the value 3.0 and y with the value 4.0. Now using blank I can go for accessing this entire memory location, but if I specifically want to access this value of x or the value of the attribute x, then I would use the dot operator and a x, okay, something like this. Now variable blank refers to a point object, okay, shown in the rectangle, which contains two attributes, and each attribute refers to a floating point number 3.0 and 4.0. And these things can also be printed. Say I want to print the y attribute of the blank instance, so print blank dot y, so 4.0 is printed. And similarly you can also go for assigning it to some other variable. Say x is equal to, I want to assign the x attribute of the blank instance to another variable with the name x, so I can do that. And when I say print x, you can just observe here 3.0 is printed. Next, so whenever I write the expression blank dot x means, so it says first go to the object blank and then get the value of x, okay. Go to the object blank, and inside the object blank there is an attribute with the name x, and get its value. That is what the meaning, okay. Now, so the purpose of the dot notation is to identify which variable you are referencing, correct, no? Or which variable you are referencing. So if there is no dot operator, so it is not possible for you to distinguish between which variable you are trying to access from an instance of the class. And dot notation can be used as a part of any expression. You can just observe here, I am just converting the x attribute of the blank instance into str, okay. Now, and the dot operator is also passed into this str, blank dot x, the entire blank dot x is passed as argument to str. And this is another expression now where we are using the dot operator, blank dot x into blank. So I want to find the distance squared, so blank dot x into blank dot x plus blank dot y into blank dot y. So the dot operator, it can be used inside any compound expression. Next is, what I'm trying to do is, say here I tried printing the value of the attribute, but now I'm trying to print the object itself. Okay, the blank is an object now, or an instance of the class. I'm trying to print the same thing. Now when I try to do it, it says point it is on. So this blank is an object of type point, and there is also an unique identifier displayed for the point object. Okay, so this is the unique identifier for this object. This it's a very big number which is displayed, hexadecimal number. Okay, and which acts as an identifier for this object, or you can say this is a unique number. So I don't know whether you people still remember it or not. So when we started our Python course initially, along with the functions, we discussed one function called as an ID function. Now to ID function, if you pass any parameters or any variable, it will print the unique ID associated with that variable. So and this is exactly the same. Okay. Now whenever I try to print the instance of a class itself, it says it is an object of type point class, and at this you can also consider this as some memory location where the instance blank is currently residing. Okay, or else you can also view it as an unique identifier which is identifying this particular instance of the class point. So now try to do this. So write a Python program to create class point object, and then use ID function to print the object's unique identifier. So print the point object and translate the hexadecimal from to the decimal and confirm the match. So because here you got to create a class called as point, and then create some instance to that point class and try to print the object itself. When you try to print the object itself, you get an ID something like this, and try to pass the same object as argument to ID and see what ID prints for you. So ultimately, so the ID printed by the ID function when the object is passed as argument to ID, and when the object is passed as argument to print, they should be same. Okay, yeah, try to do this. Yeah, have you started writing? Hello?
Yes, sir.
Yeah. So I'll show you. Say this is the program, class point. I've written pass because I'm not writing anything inside it. Then creating an instance of this class with the name blank. Okay, and point as the constructor to my class, and then so blank dot x is equal to 3.0, blank dot y is equal to 4.0. Now I have assigned x value as 3.0, y value as 4.0 for this particular instance, and then so decimal data, I'm just trying to print the ID of my blank object. I'm passing blank object as argument to ID, and printing the same. Okay, and then printing the object blank. So the object blank itself I'm printing. This gives me the decimal value, and this gives me the hexadecimal value. Now what I'm doing, so blank is equal to data. Okay, I'm just trying to split the value of the blank. Okay, using space as the delimiter. Why I'm using space as the delimiter? Because you can just observe here. So this is what I get when I pass the object as argument to print, and this string is separated by spaces. So I'm interested in only this part, and to access this part, so I'm splitting this string using space as the delimiter. Okay. Now when I use space as the delimiter, this string will be split into 1, 2, 3, 4, 4 separate strings. Okay. I'll just show you here. Yeah, I'm using split. using space as the delimiter, this is going to split into 4 separate strings, and data list is the list of strings right now, and in that list of strings I'm interested in what string. This is the first string, this will be the second string, this will be this is 0th string, first string, second string, and this is the third string. I'm interested in this. So hence what we are doing here, I'm just printing the data list. It's going to print all the strings in the data list, and after that I'm interested in the third item in the list. Okay, I take that and I'm doing R strip. This also you have understood, R strip, this greater than symbol. So because that hexadecimal value, it has the greater than symbol also, I have to pre-process and I got to remove this symbol also from the third string. Okay, I'm stripping that. Next I'm converting, it's basically an hexadecimal value. I'm converting that hexadecimal value into the decimal value, okay, of base 16, and then I'm just converting this into a string and printing it on the screen, and I'm checking if decimal is equal to decimal data. So both ID in decimal and hexa are same. Okay, we'll go for executing this quickly. I'll show you when I execute, you'll understand properly. Observe now. So ID of the blank in decimal, this is what it is printed. So I'm getting the ID, this is in decimal. Now when I said print the object blank, so this is what is printed. Okay, in this I'm interested only in this part. So this is my message. Printing the object blank is my message. Now, but what I'm doing here, data is equal to blank I'm doing on the data, so you have only this much. And this again I'm splitting here by using space as the delimiter. And then, so printing the data list. You can just observe the data list now. How many strings are there? This is a list now. This is a list. This is one string, a string at the 0th index. This is the string at the first index. This is the string at the second index, and this is the string at the third index. Now data list of 3, I'm accessing this, and from that I'm removing this greater than symbol also. Now after removing, now what I got is a completely hexadecimal number. Okay, and this hexadecimal number I'm converting into integer and assigning it to DEC, and then printing it. So this hexa in decimal is this much. Now see what ID has printed me, and what is the decimal equivalent for this hexadecimal? Same. So they both are same. Hope you people understood. Hello?
Yes, sir.
Okay. Now, is it possible to pass the instances as arguments to the functions? Yes, it is possible. Instance of any class can be passed as arguments to function in the normal way or the usual way. So for example, so I have the point class defined here, and this is the creating an instance to this class point, assigning the attribute values. X value is 1, Y value is 2, then making a call here. I'm writing the definition of the print point. Okay, and here I'm calling print point. Print point, what I'm passing is the instance of the class point, that is P instance gets copied to this, and when I say x is equal to x is equal to p dot y, so the attribute x attributes of the P instance gets printed, and similarly Y attribute of P also gets printed on the screen. Like this, you can go for passing an instance of the class also as argument to the function. So hope this is clear. And we'll execute this.
Yes, sir.
Yeah. say now x is equal to 1, y is equal to 2. So this is my point class, and this is P is the instance that is created to my point class, assigning the attributes here, making a call to print point by passing that instance as argument, and so the definition of print point is receiving the instance and then printing the values of the attributes of that particular instance. Next, sameness. Okay, so sameness, the meaning varies from one context to the another. Okay, so meaning of the word seems to be perfectly not clear until we give it some thought. Say for example, this one, Ramu and Shamu have the same car. Okay, means that Ramu and Shamu have the cars with the same make and model. Okay, but they are of two different cars. Okay, the sameness here in this context is different. We say Ramu and Shamu have the same car, but it doesn't mean that. So they are using one car. So they have two different cars, but the make and model is same, something like that. So in the second instance, okay, so Bamu and Mamu have the same mother. Okay, now means that the Bamu and Mamu mother is the same person. Okay, so the idea of sameness, it is depending on the context. So the sameness context here is different, and the sameness meaning here it is different. In the second context it is different. Okay, and the sameness meaning here in the Python programming language with respect to the object oriented programming also varies from one context to the another context, and the same thing what we are going to understand now. Sameness of objects. So on objects, again there is a similar ambiguity because the meaning of the sameness varies from one context to the another context. So to find out if two references refer to the same object, we use double equal to operator. So if I want to find out, check out whether both the objects, two references are referring to the same, or two pointers are pointing to the same object, so I can go for using the double equal to operator. So here is an example in order to demonstrate the same. Say this is the P1 is the instance to the point class. I'm creating an instance with the name P1 for the point class, and then assigning x attribute value as 3 and y attribute value as 4. Then I'm creating second instance, another instance to the same class point, assigning x instance value as 3 and y instance value also as 4. Now when I say P1 is equal to P2, okay, it is saying me false. I am just trying to check whether both P1 and P2 they are referring to the same object. Right now they are not the same object. So P1 is totally different object and P2 is totally different object. So even though their attribute values are same, see x attribute value in the object P1 is 3 and x attribute value in the object P2 is also 3. Even though their attribute values are same, P1 is not equal to P2 because P1 and P2 are totally two different objects. As we discussed here, Ramu and Shamu have the same car. Okay, means they have the same car with the same make and model, but they are two different cars. Similarly, here also, so the attribute values may be same, but P1 and P2 they are not the same object. They are totally two different objects. Okay, so hope it is clear. I take one more example in the next slide. Okay, we'll execute this quickly and see whether we get the same result or not. Oh, this one I have to remove. See, false is the Boolean value that is written by P1 is equal to P2. So it says they are not the same objects. They are totally two different objects. Next, Then the other example, so what I've done is, see, I'm creating an instance to my class point with the name p1, assigning the x attribute as 3, y attribute value as 4, and there is another instance created to the same point class with the name p2. Now what I'm doing, I'm saying p2 is equal to p1. Okay, p2 is equal to p1. I'm initializing instance of the point class p1 to the p2. p2 is another instance of the same, but this p2 and p1 now they are referring to the same object. Okay, now the output is what? True you are getting. Okay, and this type of equality, the equality what you done here is called as shallow equality, because it compares only the references and not the contents of the object. Okay, so here if I just go into the content of the object p2, so we don't have the attribute x and y initialized with 3 and 4, but the attribute x and y inside the object p1 is initialized with 3 and 4, but still it is saying the answer is true, or the boolean value when I say p1 equal to p2, it is giving me true. So this is what is called shallow equality. So it is just comparing now, this is just comparing now only the references and not the contents. Okay, by comparing the references, it is saying both p1 and p2 they are pointing to the same object, or they are referring to the same object. Okay, now here it's different. Okay, they're totally two different objects, even though they have the same attribute values for x and y. So let me go with this. Now true is the answer written by this boolean expression p1 equal to p2. OP people understood till here? So OP people understood?
Yes, sir.
Okay, thank you. Next, so shallow equality is this, that is comparing the references, correct, no? And not the contents of the objects is called as shallow equality. And we have the deep equality as well. Now what is deep equality? So deep equality involves comparing the contents of the objects. Okay, now I'm doing here, I'm creating again an instance for the point class with the name p1. See, x is initialized, y is initialized. So another instance is created for the same. Okay, there is another instance created p2 for the same point class, and x attribute for this instance also initialized to 3, and y instance is also y attribute also initialized to 4 for this instance. I'm calling the function same point p1 and p2. See, you have understood that the instance can also be passed as argument. p1 and p2 are passed. Here I am just checking if p1.x is equal to p2.x and p1.y is equal to p2.y. Now what we are doing now, so comparing the contents of the object. Okay, and if this is also true and this is also true, what this returns is true. So this is what is called as deep equality. So deep equality goes by comparing the contents of the object, whereas shallow equality goes by comparing only the references of the objects. OP people understood? Okay, now here so true I am getting. So in case if I go for changing the value of the attribute of one of the instance, I get the false as the value. So let me change this to 5. Okay, one statement is missing. Now I get it as false. Okay, next. Now embedding an object within another object. Okay. So in order to understand how to embed an object within another object, we take the example of class rectangle. Okay, we'll take this and we will try to understand how to embed an object within another object. Okay, there are few possibilities. Say for example, if you want to build a rectangle, what are the different ways to build the rectangle? There are few possibilities. One is to specify any two coordinates of the rectangle and its size. Okay, so that is width and height you have to specify. So the other approach is to specify one of the corner and the size. So one corner you specify and then the size you got to specify. So other approach is specifying two opposite corners. By specifying two opposite corners, you can go for building a rectangle. Okay. By the conventional, the normal or the usual method of building the rectangle is to specify the upper left corner of the rectangle and the size. Okay, any one of these approach or possibilities can be used in order to build the rectangle. Now here is the example on the rectangle in order to demonstrate the embedding an object within another object. Okay, so again what you can see here is the class rectangle. Okay, I've created a class with the name rectangle. So I've created an instance with the name box to the class rectangle, and then box.width. To this instance I'm adding an attribute with the name width, initializing with 100, and I'm adding another instance with the name height, initialized with 200. Okay, now box is already an instance. So box is an already instance to my class rectangle. Now I want to embed another object with the name corner inside the box object. Now that is also possible. Say box.corner is equal to point. Now what it is going to do, it's going to create another object with the name corner which is embedded inside the box. You can just have a look into this diagram. Okay, box is this outer object and corner is the embedded object. Okay, now to again specify the x and y attribute for the corner. Okay, so box.corner.x, box.corner.y. So 0.0 and 0.0. This is basically the origin what I am assigning here. So x value is 0.0 and y value is 0.0. The box here, it is pointing to this object, and this object in turn has one more object with the name corner which is pointing to another object holding the attributes x and y. Is that clear?
Yes, sir.
So like this you can go for embedding the object to any depth. So the nesting of objects can be done till any depth. There is no limitation as such. So for example, inside the corner I want to create another object, so you can always do that. Now how to do it? Box.corner dot, and again one more variable name is equal to the name of the class. Okay, so that creates another nested object inside the corner object. Okay, there is no limitation, so this nesting can go to any depth. So let me execute this. So created. Now there are two objects created or two instances created. So box is one instance, corner is another instance, but the corner is nested inside the box instance. So if you want to access any of the attributes of the corner instance, so directly it is not possible. First you have to access the outer instance, that is the box, and then you have to go for accessing the attributes inside the corner object. Next, so instances as the return values. Okay, So here you'll understand, in the previous slide you understood how to pass an instance as argument to the function or the method. Now you are going to understand how to return an instance as an argument. Okay, so if you just look into this example, this is same which I explained in the previous slide. That's the same thing is copied and pasted here. Now here I'm just calling a function with the name find center, and to that I'm passing my instance box. Okay, and then print center, print point, another function which I'm calling is print point. Now when I call find center, this is the function that is called, and the instance box is passed as argument to it, and inside this function or the method find center I'm creating one more instance with the name p. Okay, now p dot x is equal to, I'm accessing the attribute x which is present inside the corner instance. You can see how you are accessing it, and then I access the width of the box and I divide it by 2 because I am interested in finding the center of my rectangle. So and that I am assigning it to p dot x, and similarly p dot, this p is another point. Okay, another instance of the point class. Similarly I find the mid of the corner y, okay, by adding that with the height of the box and dividing by 2. So p dot y, and what I'm returning now is p. Now what is this p? P is not just an ordinary variable. It is another instance of the class point which I'm returning. Okay. Now find center is going to return you the p, and which gets assigned to center. The center is again it takes the instance p assigned. Now I'm calling print point center now. So this is the definition of the point, print point. Now p dot x and p dot y, I'm just printing the center value. Okay, so if you build a rectangle using this origin, see the origin what I've taken now here is not 0 0, I've taken it as 10 10, and this is the width and this is the height. You just draw this rectangle and try to find out the midpoint. You'll get it as 60 and 110. Okay, okay, people understood with this example? Is it clear?
Yes, sir.
Okay, so we'll execute this quickly. See, 60 and 110. Okay, so in the previous slide here I had initialized it to 0 0, but in the actual working example I have taken it as 10 and 10. Okay, yeah, so with this example you understood that the instances of a class can also be returned. Okay, so you can also go for returning instance as a return value. Next, objects are mutable. So we understood strings, we understood lists, and you understood that strings are immutable, whereas lists are mutable. What about objects? Objects are also mutable. Okay, so how do you say the objects are mutable? See, box dot width is equal to box dot width plus 50. So I have the attribute width specified at the LHS, attribute width of the object box, so specified at the LHS, and that is being updated to a new value. Okay, so say I want to increase the size or decrease the size of my rectangle, you know, so I can go for doing it by using the attributes of this particular object on the LHS. See, box dot width is equal to, I'm increasing the size of the width of the box by 50 more and increasing the height of the box by 100 more. So this should increase the size of the rectangle. Hope you understood.
Yes, sir.
Okay. Now this is the example to demonstrate the objects are mutable. Okay. Say I just want to increase the size of the rectangle. What I am doing here, so class rectangle is defined, then creating an object to the rectangle, okay, with the name bob, and bob.width is equal to this, bob.height is equal to this, and corner also I am defining a nested objects inside the bob with the name corner. So corner value I have taken it as 0.0 and y value I have taken it as 0.0. Then I am calling the function grow rectangle by passing the bob object. See, when you are passing the bob object, so internally, so it implies you are passing the corner also, because the corner is nested inside the bob, and then 50 and 100, because I want to increase the size of the rectangle along width by 50 and size of the rectangle along height by 100. So this is what I'm the definition. Now the bob is what I passed, and here it gets copied to box. So box dot width is equal to increase it by d width, and box dot height is equal to increase it by h height. Okay, and finally I'm printing the new width and height of the rectangle. You can see here. So initial height width of the rectangle was 100, increased from 100 to 150, and initial height of the rectangle was 200, and it has increased from 200 to 300. Okay, hope it is clear.
Yes, sir. Yes, clear.
Okay. So next I have an exercise for you people. Write a function named mutRectangle that takes rectangle and two parameter named dx and dy. It should change the location of rectangle by adding dx to the coordinate x of corner and adding dy to y coordinate of corner. I hope people can do this. This is an easy one. So similar to the previous one, but in the previous program you added it to the attribute of the outer object. Now you got to add it to the attribute of the inner object, that is the corner. Yeah, start writing it. So now this dx and dy component you have to add it to the attributes of the inner object, that is the corner, which is nested inside the box rectangle. Please mute.
ಇವಾಗ ಏನು ಹೇಳು? ಹಾಂ
185, please mute. 18 CS 185.
ಒಂದು ನಿಮಿಷ ಹೇಳು, ಅಟೆಂಡೆನ್ಸ್ ಅಂತ ಮಾಡ್ತೀನಿ.
18 CS 185, please mute.
ಆಂಟಿ ಫೋನ್ ಮಾಡು ಅಷ್ಟಿದ್ರು. ಏ ಇಡಮ್ಮ, ಏನಮ್ಮ ನೀನು?
Okay, keep writing the answer for this. I mean, while I'll take attendance.